Welcome all. Till now we have studied the sequential logic circuit part 1, in which we studied about flip-flops, types of flip-flops. Today we are going to study regarding the sequential logic circuit part 2, in which we are going to see what is shift registers and types of shift registers. So we studied the flip-flop, which is a 1-bit memory cell and which can be used for storing the digital data. If we want to have, or if we want to increase the storage capacity in terms of number of bits, so we have to use a group of flip-flops. Means if to store 1 bit of data we require 1 flip-flop. Similarly, to store 2 bit of data we require 2 flip-flops. To store 3 bit of data we require 3 flip-flops. Likewise, to store n bit of data we require n flip-flops. Such group of flip-flops is known as a register. Thus, register is a group of flip-flops, and the n-bit register will consist of n number of flip-flops, which is capable of storing n bit of data. Now we will see the data formats which are available in serial or as well as in parallel form. The data can be entered in serial manner 1 bit at a time, or in parallel form, in which we are going to have all the bits at the same time into a register, and stored data can be retrieved serially or parallelly. The only difference is in serial data format we are going to send or receive a single bit at a time, whereas in parallel form we are going to send or receive all the bits available in a given data at a time. A 4-bit digital data, that is 101, is represented in serial or parallel form in the following waveform. 1011, this is for serial form, in which 1011 have been shown for different interval of time. The data 1 is shown by logic high level, whereas the data 0 is shown by logic low level, one by one after particular interval of time. Whereas in parallel form, all the data, that is 1011, is shown simultaneously. Means this 1, this 0, this 1, this 0, shown simultaneously during this much time of interval. So this is how the serial and parallel data can be shown in the form of waveform. Now we will see the classification of registers, which are classified on the basis of how the data bits are entered and taken out from the registers. The registers are classified in 4 possible modes. First one is serial in, serial out mode. Second one is serial in, parallel out mode. Third one is parallel in, serial out mode. And last one is parallel in, parallel out mode. Now we will see one by one. Before that, we are going to see the buffer registers. Buffer registers are used for temporary storage of the data. This is the buffer registers, which consist of D flip-flops having 4 D flip-flops to store 4 bit of data. Each bit is given as an input to the D input of each flip-flop. A common clock pulse is applied to each flip-flop and outputs are available as Q3, Q2, Q1, Q0 in the form of 4 bits. Let us assume that the flip-flops which are used in these registers are D flip-flop, which are negative age triggered flip-flop. So let us assume that the word to be stored is 1010, means 1010. This data we are going to store in this register temporarily. These bits are connected to the D inputs of 4D flip-flop as shown in the figure. Then a common clock pulse is applied. Corresponding to the first negative edge of the clock pulse, the outputs of all the D flip-flops will be available as per their respective inputs, means we will get output as a 1010. Even if the inputs are now changed, means if I change this as a 0, this as a 1, this as a 0 and this as a 1, then also the output will not change. It remains latched as a 1010 till the next negative edge of the clock arrives. So this is how at first negative edge of the clock the outputs are latched and stored into the registers. Now we will see the 4 modes or 4 types of shift registers. The binary data in a register can be moved within the register from one flip-flop to other or outside it with the application of clock pulses. The register that allow such transfers are called as a shift registers, and these are used for data storage, data transfer and certain arithmetic and logical operations. We will see how they are used in arithmetic and logical operation further. Now we will see our first type, that is serial input, serial output data, in which we can shift the data towards right direction or we can shift the data towards left direction. In serial input, serial output, the data input is given serially bit by bit and the data output is taken serially bit by bit. This is the diagram in which we are going to shift the data in right direction, and this is the diagram in which we are going to shift the data in the left direction. The second one is the serial input parallel output register, in which we are going to provide the input serially bit by bit and we are going to take the output parallelly at a same time. In the third type, the data can be given as an input in parallel form, means at a time we are going to give the input and the data output is taken serially, means bit by bit we are going to take the data outside the register. And the last one is parallel input parallel output, in which the data is given as an input parallelly and it is taken as output parallelly. So this register will be a fast as compared to other 3 types of registers, as the data input is given simultaneously and data output is also taken simultaneously, which requires only one clock pulse. Now we will see our first serial input serial output shift register with shift left mode, means data is shifting towards left direction. Now this serial input serial output register is of 4 bit, consists of 4 D flip-flops which are negative age triggered, having common clock pulse connected to each one. The first flip-flop output is connected as a D input to the next flip-flop. First data input is given as a input to the D input of first flip-flop, and data output is taken from this flip-flop 3 in the form of serial data output. Now we are going to assume, or we are going to reset all these flip-flop initially, means Q3, Q2, Q1, Q0 will be 0 initially. Now we are going to enter a 4-bit binary number, that is 1111, into the register in the left direction, and the data which we are going to apply is given as a input to the data input pin bit by bit with MSB bit applied first. The D input of flip-flop 0, that is D0, is connected to the serial data input pin, and output of flip-flop 0, that is Q0, is connected to the input of next flip-flop, and so on. Now this is the description of this circuit. Now we will see the operation. Before the application of clock pulse, let the Q3, Q2, Q1, Q0 will be 0 0 0 0. This is the table in which we are going to see how we can shift the data in the left direction serially. We are going to apply a MSB bit of the number, that is 1111, in which the MSB bit is this one, that is 1. We are going to apply that to the D input pin of this register, which is over here. So by that D input will be D0, which will become now 1. Now after applying the first MSB bit, we are going to apply the clock to the circuit. On the first falling edge of the clock, we know D flip-flop, in the D flip-flop, output of D flip-flop follows the D input. Now D input is 1, so the first flip-flop, that is FF0, will get set and the output will become 1, and all the remaining flip-flop will be having the output as a 0. Means I will explain this again. Here, before applying clock pulse, the data input of each flip-flops are, as D0 is 1, this flip-flop will be having data input of 1. Now Q0 is what? 0, which is the D input for this D1. Q1 is what? 0, which is also D input of this D2, and Q2 is also 0, which is the D3 input of this flip-flop. After applying clock pulse, this 1 will come over here, this 0 will come at the output, this 0 will come at the output, and this 0 will come at this output. This is how the data gets shifted in the left direction bit by bit. The same is shown in this at the first negative clock edge of the clock pulse. So after applying clock pulse, we will get the data as a 0 0 0 1, means this 1 came over here, this 0 came over here, this 0 came over here, and this 0 came over here. This is how we get the output as a 0 0 0 1 after first negative clock edge of the clock pulse. Now before application of the clock signal, Q3, Q2, Q1, Q0 are 0, 0, 0, 1. Now I will put the inputs of each flip-flop before applying clock pulse. Now again we are going to apply first the next bit of the number, that is 1, to the D input of the flip-flop, means we apply the next one over here. Now in this Q0 is 1, so D1 will also be 1. Q1 is 0, so D2 will also 0. Q2 is 0, therefore D3 will be 0. These are the input conditions before applying the clock pulse. Now if we apply the second negative edge of the clock to this circuit, then whatever inputs are available at the D input, they will appear on their respective Q output. Now this one will appear over here, this one will appear over here, this 0 will appear over here, and this 0 will appear over here. So after second negative clock edge, we get output as a 0, 0, 1, 1, which we can see over here. So what happen over here is that this one will come over here, this one will shift, this 0 will shift like this, and this 0 will shift like this. So this is how the data is shifting towards left direction bit by bit. So after second negative clock edge, we get the data as a 0011. After that we will see what will happen after the next clock edge of the clock input. Now again, before application of the clock pulse, the outputs are 0, 0, 1, 1, and we are going to apply the next bit, that is this one, to the data input of this register, that is D0 will be 1. Now this is our data before applying the clock pulse, in which Q0 is 1, so D1 will become 1. Q1 is 1, so D2 will become 1. Q2 is 0, therefore D3 will become 0. So now before applying clock pulse, we have D input of each flip-flop. After applying the clock pulse, whatever input available at D input, they will appear over the Q output. Means this one will appear as a Q0, this one will appear as a Q1, this one will appear as a Q2, and this 0 will appear as a Q3 after third negative edge of the clock. So after third negative edge of the clock, this second flip-flop 2 will get set its output. So we will get output as a 0111, which is shown over here after third negative clock edge. Means what will happen over here is that this one will come to the Q0 position, this one will shift, this one will shift, and this 0 will shift in the left direction. Now we will see the last bit, which is to be applied as a which is to be stored in the register, that is this one is applied as a input to this data input. Before applying clock pulse, the Q output are 0, 1, 1, 1, means in this Q0 is 1, so D1 will be 1, Q1 is 1, so D2 will be 1, and Q2 is 1, so D3 will also be 1. Means here before application of the clock pulse, all the flip-flops having their D input as a 1. So after the application of clock pulse, we will get output of each flip-flop as a 1. Means this one will come over here, this one will come over here, this one will come over here, and this one will come over here. And on the fourth falling edge of the clock, this flip-flop 3 will get set its output as a 1. So after fourth negative edge of the clock pulse, we will get the output as a 1, 1, 1, 1, which is shown over here. What happens over is that this one will come at this position, this one will shift, this one will shift, and this one will shift like this in the left direction. So this is how after fourth negative clock edge we entered all the 4 bits of the available data input. So we can summarize that using serial input serial output mode we needed 4 clock pulses to store a 4-bit word. So in general we can conclude that it requires n number of clock pulses to store n bit of data using serial input serial output mode. This is the summary table of left shift mode, and these are the waveforms with respect to the negative edge of the clock pulses. We have stored this data input, that is 1 1 1 1. After each negative clock edge we have seen how the data output is shifting in the left direction. In the same way you are going to have this homework for shift right mode. You have to explain like I have explained in these previous slides, and you have to submit this homework by the 9th of December.